This is 5.4, lesson 1. For this lesson, we are going to interpret the meaning of solutions from graphs. So our first review question is, what is a system of equations? And it is two or more equations where we find the intersection. And then what is the purpose of a system of equations? And it's to find the intersection. To find and it's a point that works for both equations. Okay, so we're going to look at a real-world example here. So it says the gazelle is 250 feet away from a cheetah when they spot each other. The gazelle starts sprinting at 75 feet per second, with the cheetah in pursuit at 100 feet per second. The cheetah keeps gaining on the gazelle, but will wear out after 900 feet. Does the gazelle outrun the cheetah long enough, or is it captured? So let's start with our information about the gazelle that's important. So the gazelle starts off 250 feet away. Okay, and then the next bit of information that's important is that it sprints at 75 feet per second. And that per, again, is going to tell us where our rate of change is. So whenever we need to write an equation for our gazelle, usually it's in our form y equals mx plus b. Well, m we already know because of this per second, that 75 is our m. And then our b is where it begins. Well, it begins 250 feet away. In this situation, though, we use different variables. We're going to use d and t. D is going to represent distance. T is time. So behind the word per, we see second, which is a time. So that's a t. So our x is going to be a t, and our y is a d for distance. Okay. Based upon this equation, we actually have this table. So at 0 seconds when it starts off, it is 250 feet away. After 1 second, it is 325 feet away. And this is filled out all the way down to 10 seconds. Then we have information on the cheetah. Okay, and it says the cheetah is in pursuit at 100 feet per second. Okay, so that per again tells us where our rate of change is. Y equals 100 x. But in our case, again, we want to use the letters d and t for distance and time. So we're going to have d equals 100t. Okay, so we're going to count the starting point of the cheetah at being 0, while the gazelle is a starting point of 250. So we fill out this information for the table. At time 0, it's at a distance of 0. It increases by 100 every second. Now what's important is that the cheetah is going to wear out after 900 feet. Okay, so after this point right here, the cheetah is going to wear out. So we have graphed all of these, or we've graphed both of these equations here. Okay, and our finish is at 900 because that's where the cheetah gets tired and stops. Okay, so at this point, we can see that our lines have not quite intersected yet. They're close, but not quite. So our first question is, a system of equations for the cheetah and the gazelle are our two equations put together here. Are these equations linear? Yes, they are both linear. They both go in a straight line. Okay, and then our next question is, what happened to the cheetah and gazelle at 10, 1,000? Well, if the cheetah didn't wear out at 900 feet and it could actually travel to 1,000 feet, the cheetah would catch up to the gazelle. But since the cheetah does wear out at 900 feet, it actually does not catch up to the gazelle in this real life situation. Okay, then here's our second problem. A homeowner has budgeted $300 to have some necessary electrical upgrades done to his house. Electrician A charges $50 per hour. Electrician B charges $105 up front and then $35 per hour. Okay, so again, let's get our information on both of these electricians. So let's start with electrician A, and they charge $50 per hour. Okay, but it doesn't say anything about an upfront fee. Electrician B charges a $105 upfront fee and $35 per hour. So when looking at electrician A, if we were to write our equation, it would be y equals 50x. However, rather than using x and y, we're going to use c for cost and h for hours. Well, since h is after the word per, it's going to be in place of our letter x, which is how we get this equation c equals 50h. For electrician B, it has a $105 upfront fee and $35 per hour. So we would have written it as 35x plus 105. But again, we're going to switch out our letters, or our variables, for c and h, which is how we get this equation right here. So from these equations, we have our two tables and we have our graph with our information. Okay, so it says, our first question, the situation that represents, or the systems of equations that represents the situation are, so we're going to have our first one is c equals 50h, and our second one is c equals 35h plus 105. Those are our two equations together. Okay, the solution to the systems of equations is what? Well, our information that we need to go off of is that they have budgeted $300. Okay, so $300 is our break-even point. It's how much he can spend, but whenever we ask for the solution, I want to know where they intersect. And they actually intersect at this point right there. Okay, and we also can see that point in our table. We see the same ordered pair. So our solution is 7,350 because it is the same in both tables. It is a solution to both equations. It is where the lines intersect. You can put any of those reasons. Then it says circle the solution in the tables and on the graph. So we circled it in the table already, and on the graph it is right here. What is happening on the graph at this point? Well, this is where the two lines intersect. The fourth question, for what range of hours is electrician A the least expensive? So electrician A is our solid line, and we see that they are less expensive from 0 to 7 hours. And then when does electrician B become least expensive? And we see that electrician B is lower than electrician A after 7 hours. Then it says, provided the job can be completed quickly enough for the homeowner to stay on budget with $300 or less, which electrician should the homeowner hire? So using our dotted line for $300, because that's the maximum he has to spend, the cheaper electrician at that time that he can get more done for is electrician A. Okay, electrician A can work 6 hours for $300, whereas electrician B cannot quite work 6 hours for $300. It would have to be 5 hours. So he should hire electrician A because he can pay for more hours with less money.